Hello everyone, welcome to KP Tutorial in collaboration with ALM Tutorial and Mac Cafe Educational Hub. In today's class we're going to start physics, and in physics we're going to start a branch of physics called classical mechanics. Well, my name is Miss Kushmiras Parveen, and I'm a teacher and a tutor by profession. So let's go ahead with the topic. Today going to be your introduction class. So in today's class we're gonna understand about mechanics, and the branches of mechanics are there. So if I ask you a question, what is mechanics? We all know that mechanics is branch of physics that which deals with conditions of rest or motion of the material objects around us, and it is one of the oldest branches of physics. So we're going to understand here the branch of physics which deals with the study of forces and motion and their relationship is called mechanics. In mechanics, we seek to understand and explain the motion of material objects and the conditions under which objects remain at rest. And we're going to learn a few basic principles of mechanics to describe and explain the motion of stars and planets, build bridges, fly airplanes, and put satellites into orbit. Now we're going to categorize this study of mechanics into three parts: statics, kinematics, and dynamics. So we're going to understand statics. What do you mean by statics? So it's a branch of mechanics and it deals with objects at rest. It is of central importance in the design of bridges, buildings, and other structures. Like even when the objects are at rest or in equilibrium under the action of several forces, we're going to deal with this branch of statics. The measurement of time is not essential in statics, but statics itself means at rest. So we study the study of objects at rest or in equilibrium even when they are under several forces. Now kinematics. First we understand the word kinematics is derived from the Greek word kinema, it's meaning motion. And in this kinematics, we're going to learn about the motion of objects and its geometrical description in the terms of quantities such as displacement and velocity. We do not consider here cause of motion. So in other words, we can say kinematics does not consider the size, shape, mass, etc. of the body. It is restricted to properties of motion. And here measurement of time is essential. The third branch of mechanics is dynamics. Dynamics is derived from the Greek word dynamis, meaning power. It is a branch of mechanics that deals with the cause of motion. Cause of motion is essential over here. We study the effect of forces in causing motion and the properties of the moving systems by studying the equation of motion containing force. Therefore, mass of the object must be considered. So in this branch of physics, that is mechanics, dynamics, we deals with the study of motion of objects, taking into consideration the cause of their motion. And we know that the name of the scientist who contributed a lot to dynamics by postulating his famous laws of motion, yes, it's Newton. So that's all for today's class. It was introduction. We're going to meet in the lecture 2 soon. Take care. Bye bye. Hello everyone, welcome to today's class. Before going ahead with the today's session, I would like to revise what we have learned in the previous class in the lecture 1. In the previous class we have understood about mechanics. So what is mechanics? Mechanics is the branch of physics that deals with the conditions of rest or motion of the material objects around us, and is one of the oldest branches of physics. Further, we can divide the mechanics into three parts: statics, kinematics, and dynamics. Statics deals with the objects which are at rest or in the equilibrium. Even those objects are under the action of several forces, and since the objects are at rest under the action of several forces, so here measurement of time is not essential. Kinematics is that branch of mechanics which deals with the study of motion of objects. In this branch of mechanics, we do not consider the cause of motion, but here time measurement of time is essential, and we know that the word kinematics derived from the Greek word kinema, meaning motion. And the third branch of mechanics is dynamics. Dynamics is that branch of mechanics where we study the motion and also the cause of motion. The word dynamics is derived from the Greek word dynamis, meaning power, and dynamics is concerned with the forces which cause motion. Newton contributed a lot to dynamics by postulating his famous laws of motion. And now in today's lecture we're going to understand why do we call mechanics as classical mechanics. So if you just look at here, mechanics based on Newton's laws of motion. Mechanics based on Newton's laws of motion and alternatively developed by Lagrange, Hamilton and others is called classical mechanics. So classical mechanics means they comes those mechanics which were developed by Newton's laws of motion, that based on the basically Newton's laws of motion and developed by Lagrange, Hamilton and others. Now in this classical mechanics, we deals with the Newton's laws and then their consequences. So whenever we're dealing with the Newton's laws and their consequences, it is called as Newtonian or vectorial mechanics. That means further we can categorize classical mechanics into two types, Newtonian or vectorial mechanics, or also we can say analytical mechanics. So now Newtonian and vectorial mechanics means it deals with the Newton's laws and their consequences, and in this Newtonian or vectorial mechanics, quantities such as force, acceleration, momentum are used with their essentially vectors. Now, the alternative and the superior schemes in classical mechanics developed by D'Alembert, Lagrange, Hamilton, and others constitute what is known as analytical mechanics. The basic quantities are scalars. In this analytical mechanics, the basic quantities are scalars, for example, say energy, rather than vectors, and the dynamical relations are obtained by systematic process of differentiation. Let's understand a little more about analytical approach. So analytical approach has the further advantage, it can be generalized to quantum mechanics where Newton's laws are not applicable. Newton's laws are not applicable here because it's based on the Newton's laws. Mechanics are called as Newtonian or vectorial mechanics. Here classical mechanics was developed over several centuries on the basis of observations on the moving objects having relatively low speeds. In 1905, Einstein, by including the experimental fact of constancy of speed of light in vacuum, proposed a special theory of relativity which modifies the classical ideas of space and time and deals with all particle speeds. The relativistic and mechanics of Einstein yields the result of Newtonian mechanics at relatively low speeds. However, the relativistic theory of Einstein does not modify the classical ideas regarding the basic nature of matter and radiation, and hence it is often studied in classical mechanics. Classical mechanics is found to be inadequate to describe the behavior of particles of microscopic size, such as electrons in atoms and nuclear particles, etc. For that reason, we have that quantum mechanics deal with this microscopic size objects. For the description of the small scale phenomena of atomic and nuclear physics, a new theory known as quantum mechanics has been formulated, which when applied to large bodies gives the results obtained by using classical mechanics. So that's all in today's class. In the next class we're going to deal with some the concepts under this classical mechanics. We'll start with the Newton's laws of motion. So basically we're going to start Newtonian mechanics or vectorial mechanics. Thank you. Bye bye.